So, hi everyone, I'm Tanishta, and we are here on the second episode of Leveraging AI into Subsurface Topics. In this podcast, we actually discuss about stuffs like geophysics, geosciences, and how new technologies like deep learning and AI can be leveraged in this domain. We'll also learn from our guests who are working on these critical problems and how they are solving those problems, what are their data challenges. And today we have our uh, a good friend from IIT Kharagpur who is Anil, and he is doing his PhD over there. His topic is subsurface exploration using magnetic techniques. So as the podcast goes, we'll kind of go over his research topic. So maybe Anil, can you please give us some explanation about the aim of your topic and what you are doing, what you are trying to find out?
Hello, Tanisha.
Hi.
Eh, So, my PhD topic is subsurface exploration using electromagnetic technique. As we know that the source of that electromagnetic technique lies in the atmosphere, which are generated by the interaction of charged particles present in the ionosphere, and the solar
Mm-hmm.
wind. So, as they have interacted, the solar wind and the ions present in the ionosphere, they generate electromagnetic field. As they propagate toward the subsurface, they again generate the secondary field by the eddy current. So that we record, the secondary field we record, like the magnetic
Mm-hmm.
field and electric field, and from that we will get the subsurface information like resistivity and the subsurface structure based on the resistivity, and we delineate our regions which are of interest.
Hmm. Cool. And what kind of data do you use in this study? I mean, what complexity of data? I mean, you already mentioned the data, but what is the complexity of data? How much raw data do you have to pre-process to include in your studies?
Like the basically in my domain, the in electromagnetics, my specific domain is magnetotelluric, where I
Mm-hmm.
use where I record the five component like three magnetic and two electrical. In magnetic, I record HX, HY, and SZ component, and
Mm-hmm.
in electric field, I only measure two EX and EY, X
Mm-hmm.
component, Y component. The
Uh-huh.
main complexity in the data lies because they are originating ionosphere. So there may be sometimes high solar activities that may also difficult to identify in the recording because we are recording continuously data like electric
Mm-hmm.
field and magnetic field. So that also sometimes lead to wrong interpretation if we are not identifying those problems, uh, those like solar high activities, low activities, or some are also like anthropogenic origins, like train lines. If there is nearby train rails lines are present, so they will also interfere the recording, or the power line cables, the electrical fences. So that is the complexity. First, we have to identify and remove from our recording.
Mm-hmm. Oh, wow. That's quite a challenging one. So what
Yeah.
kind of techniques you're using? Like what are the filtering techniques? You might be using filters and all, right? So or Fourier transforms, or I don't know which kind of equations do you
Yeah.
usually work with?
Yeah, like the filtering is the basic operation we are using in any
Uh-huh.
geophysical we pick up. Like we will
Mm-hmm.
use everywhere the filtering. So
Uh-huh.
for the simple, we use notch filter to remove
Okay.
particularly like the electrical signal are 50 to 60 hertz in like distribution. So use notch filter to remove 50 60 hertz. That is the foremost task we are doing.
Mm-hmm.
Then other like you talked about Fourier transform. Yeah, that will
Yeah.
definitely to get the phase information, resistivity information. We used to Fourier transform the raw data
Mm-hmm.
to Fourier transform domain.
Hmm. Okay. So. what is basic application? Like, where do you find this application? Like, it might not have that much consequences in oil and gas industry, right? Where do
Yeah,
you find more of it? Like, what else? Like, people mostly know oil and gas, but where else do you get this application?
as we know that in oil and gas, people like industry primarily use seismic. Then complemented, they use magnetic or gravity method. But
Mm-hmm.
electromagnetic, uh, particularly if I talk about my topic, magnetologic, that has frequency range from 10 to the power minus to 10 to the power 4.
Mm-hmm.
So that has a high depth of penetrations, like core, like not crust, mantle, up to 100 kilometer that depth of penetration. So it is not much applicable in oil and gas, but has application in subsurface studies. That one part is deeper. If we also see the shallower subsurface, then we
Mm-hmm.
also use for groundwater exploration.
Groundwater. Okay. And it's are these kind of quite are these companies there who are using these techniques, or is it very common technique for groundwater
Yeah,
exploration?
yeah, not much. Like this empty technique is very in its dormant phase. Many
Okay.
people are using resistivity method for uh, groundwater exploration. That is not
Mm-hmm.
much advancement happened in this field.
Oh, okay. Good to know. So maybe we can talk a little bit, since the topic of this podcast is how new techniques like mostly machine learning, deep learning can are be leveraged in this domain. Do you think there are research going on in regarding like deep learning applications to magnetic telluric data, or do you think it might not be as necessary at this point? Those other techniques are fine.
Yeah,
Do you,
definitely. Now, this is the era of AI and ML. So everyone
mm-hmm,
just using AI and ML. So it is definitely useful. But as I told that this is a very dormant phase or the beginning phase. Like
mm-hmm,
uh, this AI and ML are much advanced in seismic, or if we see the other fields that has much advance happened, but that is not much in compared to that MT MT method, magnetology method.
empty methods, okay. And
Yes.
so probably like new like computer visions, like the models that are used in computer vision. So these empty data come as image data, right? When you look at it, or it's a signal data. How is that look like?
Yeah,
Yeah,
definitely. Like uh, if we process the raw data, then we
mm-hmm.
get a resistivity, and if we inverse that, then we can get the subsurface image.
Ah, okay. Yeah, sure. And you might be always getting some data challenges, right? So you have to label, you don't get much label data. So um, probably are there, what I wanted to know, are there research topics, because deep learning can actually navigate this problem of low data problem. So this, are there talks going on around this? Because I know there's not much application of deep learning in groundwater exploration. However, it can find a good suitable spot over there too.
Yeah, definitely, because when we are dealing with the outliers, it is very
Yeah.
difficult because
Mm,
we are only using the software for the processing.
mm,
So
yeah.
we, one by one we have to pick. We have lots of data. Like sometimes we used to record one day complete data. So that
Yeah.
is very difficult to pick one outlier. Then again,
Outlier, yeah, from
that
this.
is very
That is
tedious job.
where you might help. Might these algorithms might be definitely useful. I am sure. Yeah,
Yeah.
and yeah, hoping that this can find a good application over there. So maybe we can talk a little bit about now. Let's see, because you are all into you are not into oil and gas, but still in a conventional domain, there is a lot of talk going around climate clean technology, right? So, what is your opinion? I definitely think a magnetic telluric is a clean technology. It's looking into groundwater. But as a geophysicist, what's your opinion? How do you look at the clean technology, clean environment stuff?
Yeah, like everywhere, if there is buzzing happening, and everybody is listening about global warming, and nowadays everywhere people are researching on that carbon captures, different method.
Right.
But I think geology and geophysics, geoscience, like people are much are helpful because they know the subsurface. Like we geophysics can image the subsurface, and we can capture the carbon, and where we can store there also we can know the regions where we can store that. So
Mm-hmm.
it will definitely be helpful, and we can do much advancement because also if I talk about my topic, that is as much deeper subsurface penetration of my metal. So yeah, definitely that will be a complementary use for those other methods.
Okay. And yeah, so and how is it looking in the Indian context? Like a magnetic telluric, probably, and maybe clean tech. Are these talks going on? Is there?
uh, Not
No, not yet.
really, not yet.
Not yet. It's a big thing. Yeah. So you mentioned about carbon capture. So maybe for the audience, can you just mention a little bit how about a general overview of carbon capture from a geologist or geophysicist point of view? What happens? Like where are we helping? Like the geophysicist helping in this process?
Okay.
Maybe in a technical term
So
or non-technical term.
okay, for that, I don't have much idea about carbon capturing or where. I know that I one of my professors from IIT Bombay is doing
Hmm.
prominent job in this carbon capturing. So I heard from him that they are capturing carbon and storing some surface formations.
Mm,
Like from that,
yeah.
where it can be escaped.
Mm, okay. Yeah. So you're storing it, like trying to find the right rock type or something like
Right?
that. Right?
Yeah,
Yeah.
definitely.
Okay. Cool. Cool. No, that is really good to know from you. Like we did cover a lot of topics, and it's quite technical and non-technical also. So probably I think the audience can learn a lot of about your research. And thanks to Anil for sharing his research and his overview on everything. It's good to learn about magnetic telluric because everyone's doing seismics, right? Seismology. Yeah.
Nice.
So okay. So with this, we'll end the podcast episode 2 for now, and stay tuned for the next episode. Thank you all. Bye.
Thank you.